I just want to make sure that I get everything through the system here. All right. Really quick forward-looking statement. We are always advised to show this slide just to make sure that there might be things in the presentation that are about to change, and you, let me put it that way, that you don't buy Cisco stock based on the information I provide here, right? So this is about it. All right. So who remembers where this is from? Do you guys know this? Nobody? Futurama? There's somebody nodding? Okay. So for you who don't know, like Futurama is one of the shows, I think it started like in the 90s, right? And this is from the very first episode. So basically the main character got frozen accidentally and wakes up 1,000 years later. And this guy is working in this facility who does this with the people, like freezing them, waking them up again. And this guy is, always making fun about the people who are waking up and then, tries to impress them like, welcome to the world of tomorrow, right? And kind of tries to shock them. And yeah, today I always remember this scene from back then because it starts to feel like that we are in this tomorrow already, right? With everything that is going on around us, like there's autonomous systems, there's self-driving cars. Then you can ask your OpenClaw assistant to make a reservation in a restaurant. And then it starts to ring the restaurant, and you know what? The restaurant is replying with an autonomous agent by themselves, right? And they are figuring out and trying to make the reservation. So yeah, it kind of feels like that we are already in this world of tomorrow. And one thing I noted as well is that the development speed, like how fast things are currently developing, is so fast, right? I mean, if you look at it, ChatGPT was announced to 2022, I think, end of 2022, and now we have those autonomic agentic systems, right? It's a very short time span, and things are moving really, really fast. And I kind of feel like Fry, right? Fry is the main character of Futurama, and he, wakes up after 1,000 years, and looks into this new futuristic world, sees like flying cars, weird-looking aliens. Okay, we don't have those yet, not yet. Who knows? And there's robots, right? There's a lot of robots like that do a lot of stuff, like autonomous robots. They are autonomously. They are built for specific tasks, and they live along the society in future, right? And it kind of reminds me again on the current world, right? We do have like AI agents now. They live along with us, and we are utilizing those to, for specific tasks, to ask questions, to do stuff, right? So yeah, and this future that we now live in also comes with a set of, or a layer, I would say, a layer of new complexity as well. We do have new possibilities, but also we do have a lot more stuff to take care of, right? And this is what AI brings into the mix now, is additional complexity. So we use AI to, not only answer questions, but also to develop code, right? To develop applications. Then use AI to fix bugs in those applications, to do autonomous operations, right? To handle the complexity. We use AI as well. There's like a lot of additional infrastructure layers as well, right? We do have new frameworks, model serving platforms. We are more interested now in GPUs somehow, right? Because models are running on those, right? So there's a bunch of things that AI now brings to the AI stack. We need to make sure it runs efficiently. And on top of that, AI is expensive, right? So if we use AI and host the models ourselves, it becomes really expensive. If we use AI using models that are in the cloud, it's also expensive, right? Token usage, stuff like that. So there's a lot of new costs that accelerates currently with the more AI I use, the more cost it generates. If you look at the power consumption of data centers, right? In 2022, it was about 460 terawatt per hour, and now 460 in 2022, and now 26, it's already at 1,000 terawatt. So the power consumption of those AI data centers, or like in general, the data centers is, accelerating. And in addition to that, AI also comes with new risks, right? So I don't know if you read this. This was a couple of weeks ago, a month ago. But I mean, it speaks for itself, right? We use AI, but AI comes with risk. Who is using AI like just on a daily basis, right? And who builds AI applications? Like who uses AI to build applications? Not so many. Yeah. And who has already an AI application running in production that, yeah, you have that? Awesome. Is it risky? Do you feel safe? No, not really. Yeah. Exactly. So yeah, I mean, this is I would say the current challenge, right? To have those autonomous systems, you need to make sure that they deliver quality, right? That they are not starting to hallucinate and give answers that are not true or that are toxic or whatever. And then you also need to make sure that there's no prompt injection, PII leakage or whatnot, right? To mitigate the security risks as well. So how can we stay on top of those new challenges, right? I would say the first step is to make this AI a bit more transparent, right? We need to better understand what is, actually, firing up those AI workloads, like where is it deployed, how does it look like, and so on and so forth. So this is what I want to show you today is how we can achieve that. But how? Yes, the title of the talk was also already giving it away. I wanted to give you some ideas of how you can utilize OpenTelemetry in order to do that, right? So there are different approaches to bring visibility and transparency into AI, and OpenTelemetry provides some of those. So are you familiar with OpenTelemetry? Is it something that you guys know? Yes? Some of them? Okay, thumbs up. Awesome, okay. For those who are not. So OpenTelemetry is, it's an open source framework basically, right? That provides a set of tools that you can utilize to collect telemetry data, whether being it metrics, logs, traces, and events, baggage. There's somebody name it this way, somebody say baggage. I think the official thing is baggage. But yeah, you can collect different kind of telemetry data from infrastructure and applications, and OpenTelemetry provides you with a set of tools to make that part easy. Right. And especially for, if you have applications, you can use auto instrumentation, like no-code instrumentation. You just, if you have a Java application or Python or whatever, you use an OpenTelemetry agent to instrument that. There's no-code and zero-code options. If you have infrastructure you want to monitor, there's OpenTelemetry collectors that you just point to your OS level, and it collects host metrics, for example, right? And the neat part of it is it's vendor neutral, right? There is no vendor lock-in or anything. It's an open source project that finally got into the graduate state of the cloud native foundation. So what it means is that it's production ready now, right? There's a lot of customers actually using it now in production, and you can feel safe to do that as well. Right. And yeah, there's a lot of support. So just look up in the docs if you have a question, if a specific technology is already supported, a specific framework or language, you can have a look at the documentation and it points you to the right sources. All right. So what recently was added, or I mean, it's still in a process, but it's in a development status, is the semantic conventions for Gen AI systems, right? Because this is now more and more relevant. The OpenTelemetry community already is thinking about, okay, how can we standardize new telemetry data, right? We're talking about, like token usage, agent spans, time to first token, time to first chunk. Like metrics and KPIs that are now becoming more and more relevant if you have an agentic system, right? Workflow duration, or even temperature. Like you can specify temperature. If you ask a question to an AI model, like what temperature should it answer, you can also collect this in a standardized way that you have it later on for analysis. Maybe to, if you do prompt engineering, to compare, okay, what did it mean if I switched the temperature to, 0.1 point up or down. So this is really relevant now that we have the standardization and can now collect this kind of information as well. Right. So the question now is, how can we connect the OpenTelemetry with the AI systems, right? And I wanted to give you just a brief example again, because I was thinking about this Futurama theme. So do you know Bender from Futurama, the robot? Who's like also one of the main characters, right, in Futurama. Do you know what Bender actually is powered by? Like, what does he run on? Like, what's his fuel? Do you know that? It's alcohol. He's drinking all the time. He drinks beer, rum, whatever, and this is like his natural source to, be able to work. And I kind of like see the parallel to AI systems now. Like, what is the main like power for AI systems, right? It's basically the infrastructure that we already know. Right? It's nothing new. Like alcohol is for Bender. It's not some mysterious future, I don't know, but it's like something that we all know. And for AI, it's the same, right? AI runs on the hardware we already have. And yes, now more a shift into the GPU direction, right? Or NPU or TPUs are now being developed, like parts that are good in processing LLMs, or, providing LLMs. And yes, this is maybe a bit new, but still, it's not like the hardware itself is nothing new. Yeah. Right. And yeah, now what it comes more to interest is that before to understand how this infrastructure is being utilized, because it's expensive, right? Buying a GPU. Like, I'm a PC gamer at heart. It's like if you try to get new hardware nowadays, it's crap, right? Because the prices went up, everything is super expensive. And if you equip your own data center with GPUs, they are insanely expensive, and you need to make sure that they run your workloads efficiently, right? In order to do that, we need visibility, right? So let's take a look on how we can get the visibility into GPUs, for example, right? So, we do that by, before I switch, we do that by utilizing an OpenTelemetry collector. Here's like a simplified architecture of that. What it actually does, it's a component that you can use as a gateway, so to speak, where you send your telemetry signals to it, or configure, like, I would say jobs, right, to retrieve information from an endpoint, right, where you can configure receivers, OpenTelemetry receivers, they're called. So on the top right, you see, for microservices, for example, if you have a Python application, just throw the OTel agent into the Python application and point it to the OTel collector. For the chat infrastructure, you can use the receivers, collecting host metrics, collecting Kubernetes metrics, and collecting GPU metrics, right? And then the data gets processed in the OTel collector and can be sent to an observability backend. Could be anything that understands OpenTelemetry, right? Just point it to there or point it to multiple ones, right? If you have different OpenTelemetry backends that you want to use. Right. So it's really simple if you have a look, because most of the components that are now being used, can you see that, or should I make it a bit better? Bigger. So on the left-hand side, you see the YAML configuration of an OTel collector, and on the right-hand side, you see a visualization of that, right? And you can see here that I simply added a receiver for the GPUs, right? And you simply point it to a metrics endpoint, and it starts to collect the metrics from there. What you can do to have this endpoint is actually to deploy an NVIDIA operator in your Kubernetes cluster, and that operator makes sure to also deploy a data center management unit from NVIDIA that provides this metrics endpoint, and then you can simply scrape it. And as you see, it's a Prometheus endpoint. A lot of this new infrastructure comes with Prometheus endpoints. I think you're all familiar with Prometheus. And an OpenTelemetry collector has a Prometheus receiver that you can use and just point it to the metrics, right? To the metrics endpoints, and it starts to collect the metrics from there. There's also from NVIDIA NIM. If you have NVIDIA NIM running in your Kubernetes environment, you can deploy the NVIDIA NIM component, and it offers a metrics endpoint as well. And this is where you can collect the metrics from. It's as simple as that. Just configure the OpenTelemetry collector to collect from those endpoints. Make sense? Okay. Right. Good. And the next part would be, like, if you have this set up, right? You collect infrastructure metrics, OS metrics, GPU metrics, right? The next layer, I would say, is also kind of familiar, right? Most of the time, it's containers and Kubernetes running on that infrastructure. There's a bunch of different data pipelines, maybe, and a new component that now is becoming more relevant if you host your own AI systems and LLMs in your own data center is vector databases, right? So there is, for example, Milvus, VV8, Pinecone, those vector databases. And guess what? They all offer Prometheus endpoints. So again, right? Just at that part, I don't know if you've seen it before. I did this here as well. Example VV8, right? Provides a metrics endpoint, right? If you have a component running, just point the collector to that, and it will take care of the rest. So you're also good to go and have your database included in the monitoring. And the next layer, I would say, that comes on top of it is then the model serving frameworks, right? There's LLM proxies, SLM proxies, like for small language models. This is also now getting a bigger thing that are now currently running in those environments. And here again, right? All this new solutions or frameworks that are being built currently, they all have observability in mind, and they come with monitoring options, and they all also most of them come with a Prometheus endpoint again, because it's like the number one thing that most of the dev and ops people are familiar with. So you can again utilize this and add it. I don't know if you've seen it. If you look up in the for example, VLLM or Ray.io. I don't know if you've looked into that, like a model compute engine that runs on top of Kubernetes that makes sure that you can distribute your AI workloads correctly. Again, to utilize the GPUs efficiently, right? Has a Prometheus endpoint. Again, just point the collector to that endpoint if you use Ray, or point it to VLLM if you use VLLM. And you're collecting those kind of information. Good. And the top layer, I would say, is actually where the application bits are running. Like most of the times, microservices and containers. You have maybe some rack applications, chatbots, or already building agentic apps, like where AI microservices like are specifically built for certain tasks and talk to each other, and then you have maybe an orchestration layer that organizes and orchestrates those agentic applications, and they talk to each other, and you do a request, and they do the heavy lifting. I don't know, like you have one specific app that does, I don't know, flight research. Then you have like an activity planner that builds some activities around your trip, and then you have another one that does, I don't know, the flight search or whatever. And then they put together the puzzle, and you are provided with a full set of information you were initially asking. And this is where agentic apps come to play, for example. And those apps, again, they are built in Python or Java. Like it's also something that we know and that we are already good at instrumenting. So you can simply add an OTel agent to that, right? Let me quickly share like how that looks. I think in this example, yes, it's a Python application, and we have a requirements txt, right? And what I did is, I added an OpenTelemetry Python agent here. This is the Splunk distribution, but there's also, you can add the open source distribution. There's a package for LangChain, right? If you use LangChain, LangGraph for orchestration, there's also an OpenTelemetry package that you can add that then understands the chat workflow within the application. There is an OTel UTel Gen AI package. This is what we saw previously, building on top of the semantic conventions that the OpenTelemetry community is now adding, right? So it makes sure that we also collect the new KPIs, for example, token usage and whatnot, right? And this one is, okay, this is just to track web requests in the Flask application, but this is basically just adding those libraries, those packages to the Python application, right? And then making sure that we also start the OpenTelemetry instrumentation with the Python application. So just make sure that you add this in the Docker file as well, that it starts with the OpenTelemetry instrumentation. Right. And if that's about it, right? If you do that, you get a full monitoring or observability stack ready to being monitored by OpenTelemetry, right? So you have the different components of your AI system. As I said, infrastructure, most of it is things that we know. GPUs we can cover now as well, right? It's not that hard to integrate those together with the rest. We have those new components like vector databases, new frameworks like Ray.io, VLLM, and others, and also the communication to the cloud backends, right? If you use OpenAI endpoint, it will be detected by the OpenTelemetry instrumentation as well, and you will see that there was a chat request going outside of your application. And it basically collects metrics, traces, and logs, transforms it in the OpenTelemetry format, and you can point it to any OpenTelemetry compatible backend. And this is actually then where the magic happens, where the correlation of metrics and logs happens, for example, or traces and logs, where you can do a lot of visualizations, but also helps you analyze your AI applications, and make sense of all the data that you collected. Right. And I mean, this is a way to standardize the instrumentation, right? If you use OpenTelemetry, you have a standardized way that is, helping you instrument your stack, and then send it to an OpenTelemetry backend of your choice. And now with the new set of information that gets collected, also helps you better understand like large language model workflows, agentic apps, helps you like in debugging user requests, like workflows that run through your AI system to use tracing, for example, to better understand how a request was processed in your system, and also capture a set of new kind of information along that. Because we have the traditional information we already are aware of, like response times, errors, latency, and stuff like that, right? And now we are also able to collect like a set of new information along that. For example, token usage, or like model parameters that you set, right, to be able to compare different requests, prompt or completion content. You can also store the input and output messages in the OTel trace, right? So if you have a chat that you want to observe, to make sure that you evaluate the input and the output to get, for example, quality metrics, like is my model hallucinating? Is the response toxic? Is it biased? And so on and so forth. The first step in order to do that is to collect the actual message, and that can be done with OpenTelemetry. And then you need something that evaluates the messages, right? Like LLM as a judge, or small language models that are way quicker in pointing you into the right direction, saying, okay, this is a good response, this is a bad response, to make it easy, right? And also evaluate it for security risk, right? Have a check. But the first step is to actually get that information and then have it evaluated. And with OpenTelemetry, this is pretty easy. And then, of course, the token cost and usage metrics that are also captured automatically, that you need to understand in order to make your whole stack run efficiently. Right. So yeah, this is like kind of the full circle here, right? So you can utilize OpenTelemetry to compensate for the complexity, because you can use the OpenTelemetry signals to visualize your environment, to understand dependencies and performance. With the additional information we collect, you are also more aware of how your infrastructure is being utilized to address the cost point, right? But also like tokenomics, like how performant is my model running on my GPU? Like, do I need another model and get the same response, but it runs quicker or with less power consumption, right? To evaluate those kind of use cases. Yeah, and the last bit is to also make sure that it's not being used in a way it shouldn't be, right? To understand what is the input, what is the output, how are the agents talking to each other, right? Is because when the first one is producing like a bad output, the second one uses that to do whatever the second agent is supposed to do, and then you have a chain reaction. So make sure that you understand how those interact with each other, and make use of the information that you can collect. Right. So yeah, just I'm from Splunk, you know that. I don't want to show you Splunk right now, but if you're interested, right, in how that looks like in Splunk, we have a booth downstairs where you can have a look how like how Splunk as an OpenTelemetry backend processes and visualizes the data and also helps you understand in troubleshooting use cases, security use cases, risk use cases, and quality use cases. So if you want to have a look, please come by and I can show you around. And if you don't have the time today, there's also the opportunity to just check it out online. We have a demo playground where you can have a look what Splunk does with the OpenTelemetry data, right? Good. I mean, this was about it, right? I just wanted to show you guys that it's actually pretty simple to use OpenTelemetry to get more visibility and transparency into the AI stack that you might or might not have running already. Yeah. Thanks. And questions, if somebody. You can. No? All clear? Okay. Yeah. Yes. Mm-hmm. Mm-hmm. Yes, I mean this is what we are doing already, right? With things like Chef and Puppet and like how you automate stuff, because the first thing, this is not like our collector or agent. You can use the open source OpenTelemetry collector, right? And then you need to think about a way like how can I deploy this on my environment, right? Like, do I need it on the host system? Do I want to have it in the Kubernetes environment, for example? And or do I also want it in the application, right? And then you can, utilize your deployment mechanisms that you already have, right? And just add that part to it. Because, you can, you can send OpenTelemetry directly from within an application, and you can also use an OpenTelemetry collector in between, kind of like as a gateway, right? And the OpenTelemetry collector can be in a single, like in a central instance, and then different systems are sending to that, for example. Or if you want, to have one on each VM, for example, you need to make sure to put one on each VM. But it's not like something that we offer. It's more like that we can adjust to whatever way you already have in your environment. Because most of the time that, customers use Ansible to roll out different artifacts on their systems, and you can simply, you use OpenTelemetry for that as well. Put OpenTelemetry in that pipeline as well. Make sense? Okay. All right. I'm here. I'm staying here for a couple more minutes. If you have any questions and want to, talk to me in private. Other than that, you're good to go, guys, right? I don't want to hold you hostage here. And yeah, if you want to have a look, come by at our booth downstairs. It's really interesting what we can do with the data already. But yeah, I didn't want to, I just wanted to give you a more general overview of what OpenTelemetry can do, and then there's a lot of, more like products that build on top of the data that you collect, right? And what you can do with it automatically, or like how data gets visualized, so data gets correlated and stuff like that. There are different options out there. You can, use a vendor-free option, like an open source option, but there's also a lot of different vendors that can process OpenTelemetry, and we are one of them.